This is a video about UPS types and how they work. Visual explanation of uninterruptible power supplies, how they operate, and it will be followed with a comparison of features. Let's start out with the transient voltage and surge suppressor, or TVSS. And I'm going to basically power in and power out. As this operates, it's a surge. You see power on the line, and then you see as a surge comes in, basically this blocks them from passing through. Next thing we'll look at is a automatic voltage regulator. This comes in a variety of forms. It's been around for quite a while. Essentially, we power this up, and when we have a larger incoming voltage, the output stays essentially the same. And also, if we go with a lower input voltage, again, we'll step it up so that we have essentially the same output voltage. Now we'll take that surge filter, move it to the end, and take a look at a standby UPS. This is sort of the lowest level of the UPS, and basically provides a battery backup. So we'll start with the battery and an inverter to convert that DC voltage from the battery to AC. Put those together. And we'll put a transfer switch in line, connect that to the converter. Put in a battery charger to charge the battery. Connect that to the power coming in, and connect that to the battery. Put in a control circuit. This will be the circuit in place where it receives voltage information from the battery. In turn, it'll be able to turn on the battery charger when that voltage is too low. To look at the incoming line voltage, and if that voltage is out of specification for what it's supposed to be, it can activate the inverter, and also has a connection to the transfer switch, so it can transfer over to battery power. There'll be an alarm circuit, and this will be designed to tell you if something's out of whack with the system. So I'm powering this up. We'll see that we end up with power to the battery charger and going through the filter at the end and to the output. We have an alarm set right here, and it's because the battery is discharged. It needs to charge up. So we're showing a discharged battery alarm. The control circuit will turn on the battery charger, which sends power to the battery. When the battery has charged up, we'll see it sends out power to the voltage, tells the control circuit, which is able to shut off the charger. When the power goes out to this unit, we'll see that we set an alarm, and a number of things happen, but basically the control circuit turns on the inverter, flips the transfer switch, and now we have an alarm set because of the fact that there is no power on the input. So again, going back to our standby mode with a charged battery, we'll look at one more time, loss of power, and alarm signal from the control circuit and the transfer switch, and we have the power coming out. Next, we'll look at the another type of variation of the standby UPS. Move that control circuit a bit, and we'll place in an automatic voltage regulator. This gives us the line interactive type of UPS, and it's an enhancement of that standby type, in that it also it adds the features of the automatic voltage regulator so that it doesn't go into battery mode with the same narrow range of voltages. So it enhances the performance by reducing the amount of the conditions under which it would be under battery. And the next type of UPS is the online UPS. This one uses different stages. It's quite a bit different from the way that they standby. We start out with transient suppression and filters on the input. We have a rectifier, power factor correction stage, an inverter, which is what we also had with the standby UPS, and then finally an output filter. We basically connect these together. After the input filter is the rectifier. It converts to DC. That DC goes into an inverter, which in turn goes to the output filter, and it provides the output of the unit. So essentially, this works full-time running these stages. And then we add some components to that. Put a transfer switch in here, although not for the same purpose as on the standby UPS. This is basically a transfer switch that's used to transfer around the whole UPS to take it out of the circuit. We'll have a battery, a DC to DC converter, which will be hooked up to the battery, and that in turn will provide power to the inverter. We'll have a battery charger, which is hooked up to the line voltage coming in, and that of course will charge the battery. Control circuit, and that'll look at the input voltage. It'll have the ability to control the DC to DC converter, turn that on when needed. It'll check the battery voltage and the ability to turn on the battery charger to charge the battery. Then it'll look at the output voltage and have the ability to operate the transfer switch. And finally, there'll be some alarms, and the control circuit will be able to turn on those alarms. So when we power this unit up, we see that it provides power to the battery charger, which is not on. It goes through all the stages and provides voltage output. Notice that all the voltage that's provided at the output is coming through the rectifier and inverter. So this one is constantly has those online. It's not just when the power goes out, but there's always that total isolation between the input and the output, and that the whole input power is converted to output. Now we have an alarm on because of the fact the battery needs to be charged. So that's detected as a battery voltage. When that goes up, it turns off the charger. So now we have a fully charged battery. If we lose power, you see that there's not a whole lot of change, nothing really transfers. We have an alarm for the lost power, but basically the battery is providing the DC that goes to the inverter instead of the rectifier. So no transfer, it's no break whatsoever in the output voltage. Now we'll go back to the normal condition on the UPS, and we'll look at another possible fault condition that could occur with the UPS. And that would be if we lose output from the inverter or the output filter. You see, as that goes away, that will set an alarm. The control circuit detects that and flips the transfer switch so that now the UPS is no longer in the circuit and the output comes directly from the input. So this would be in the case of something goes wrong with the UPS. Now there is very brief delay, not enough to really be a problem, but this is where there's a transfer delay on the online UPS. The line interactive has a transfer delay on the when there's a fault on the input power. So now we'll look at a comparison of the features of these two principal types of UPS, which would be the line interactive and the online. The line interactive is very little more expensive than the standby type. So most of the ones, particularly in commercial use, are the line interactive at the lower end. The line interactive has a lower initial cost than the online. It's because it doesn't have as large components in it in terms of the rectifier, and it's not working the same amount of time. The line interactive is typically larger physical size. Online would usually be somewhat smaller, Line Interactive operates at a higher efficiency because of the fact that most of the time the inverter doesn't have to operate. And so it can charge the batteries up and then provide very little power consumption from the unit itself. It's just passing the power through. Because of the fact that it's doing less during normal operation, it produces less heat as part of that efficiency. However, since the Line Interactive has not quite the range of input voltages that it can handle, typically the Line Interactive might go from 90 to 140 volts that it can regulate the power and still produce say a nominal 120 if it were operating normally at that range. And the online may go as low as 60 and up to 150, 160. There are less circumstances for the online to actually be going into batteries. And so batteries are under less stress, so typically there's longer battery life on the online, and that can actually make up totally from the difference in the initial cost. As we said, the Line Interactive would spend more time in the battery than the online. Probably the principal downside of the Line Interactive would be that a UPS is sometimes required to deal with legacy equipment issues. Modern electronic equipment, computer equipment, is able to handle brief outages, has a reasonable input power factor, and doesn't require the kind of power conditioning that the older equipment did. So if you had older equipment, you can have problems both with the operation from line voltage fluctuations that are totally isolated with the online UPS, and also that equipment can cause power factor issues with the utility, with the power that's coming in to the building. So the online can totally isolate that legacy equipment and prevent problems both in the building and problems with the equipment itself. So this would be sort of a comparison. Line Interactive is typically found in 5 kVA and under. Online is available in those sizes, but beyond that, the online is more common UPS. Further information, go to drinfrastructure.com.